Hi, my name is Francisco Javier Díaz Islas, and this is my video for the robot trajectory in MATLAB and Simulink. Well, so for the first point, we have to get the mathematical equation of the velocity with using derivative functions. Sorry. Well, so this is my procedure. So we start with the diagram of the robot and we take out the component that we want. We, for example, have YR and XR. And also we have the velocity, which is sine of theta, theta being the angle of the steering wheel, and also velocity cos theta. So we already know that velocity is also the derivative of position. So having this in mind and having as a reference point the center of the automobile, well, we can get the following data. So first, P center point between the wheels, every wheel, and I being L being the distance from every wheel to the center point. Y1 and Y2 equals spinning velocity of each wheel, and R being the wheel diameter. So we already know that the angular velocity is equals to velocity over radius. So we can just move and search for velocity, which we have angular velocity times radius. So the radius, we can also transfer it to being r minus r plus L, because having the center of the car as a reference point, we for example have one in this side and the other in the next side. So we have two wheels with two possible outcomes. So like this, we just turn here and we get WL, and now we search for W and we get the derivatives, and we will need to arrange it in a matrix for this. So for the next point, we'll actually need to use MATLAB. Okay, so for the next point is to consider first this trajectory, and using MATLAB to generate trajectory, a linear trajectory, with at least 3 sections considering this position using Simulink. So let me share. So we need to have in mind that there is, for example, a place called GitHub in which we can download some programs and just as the Peter Court's toolbox, transfer it to MATLAB so we can get this. So for example, we need to open the file that this is called SL Pursuit, and we'll have our Simulink program. So let me zoom in. Okay, there. Okay, so with this, this is a Simulink program that will help us to plot the trajectory using a PID controller for the speed control and the distance to the goal. And we also have our trajectory, our desired trajectory here. So for example, we want here to substitute data with the one we also want. And for example, I already placed it. These are the points, which, sorry, I'm not sure. Okay, so these are the points, and which also coincide with the ones that I already fill here. So we hit OK, and we now go to MATLAB, and we need to run the simulation. So we just use this command in SL Pursuit. We run it, and we now get our desired trajectory. Okay, so now that we have our desired trajectory, we can go on to the next point. So the next point is now considering this problem of a robot moving to a position or a goal. We need to implement a solution to the problem and make a simulation on MATLAB. So for this, we can also access GitHub to help us with this, which will also give us a Simulink program. So this one is called SL Drive Post. And well, it was all loading. So here we have the simulation in Simulink for the robot and our desired position. So as you can see, we have many variables such as rho, alpha, and beta. And we also have here our desired position. And here we'll have the alpha and beta graphs, which are the ones that are going to give us the desired positions graphs. So if we just do the same here, actually, I can run it from here. Oh. Oh. Okay, so we can see that alpha is our current trajectory, the one that we have to do. For example, here. And beta is a more linear trajectory. As you can see, the curve in the graph is less pronounced. So it's like the displacement. And here we have distance. And I think this is everything. And thank you so much.